In the quiet hush of twilight, when the world slows its turning and thoughts begin their gentle wandering, we find ourselves drifting upward, beyond the thin veil of our atmosphere, into the vast emptiness where planets hang like distant lanterns. Tonight, we follow a trail so faint that most have never noticed its existence. The whispered path left by an object known to astronomers as 3I Atlas, a traveler from beyond our solar family. Its journey brings us toward Venus, that golden sphere wrapped in perpetual clouds, keeper of secrets older than human memory. Nothing rushes here in the deep between worlds. The cosmos moves to rhythms measured in millennia, in the patient turning of galaxies. We drift alongside stardust and silence, wondering why a wandering interstellar object would brush so close to a world that hides its face behind swirling gold. Perhaps there is meaning in such encounters, or perhaps it is merely the random dance of matter across the void. As we glide through darkness punctuated by ancient light, we listen for echoes of something that has already happened, a meeting between stranger and mystery, between the emptiness beyond our sun and the shrouded world that has captivated dreamers since we first looked upward. The darkness between stars holds its own form of luminescence, a subtle glow that comes not from any single source, but from the collective breath of distant galaxies. This cosmic background light embraces us as we journey, a reminder that even in the deepest void, we are never truly in absolute darkness. Our path toward Venus traces a line through this gentle illumination, following mathematical projections of where 3I Atlas once traveled. The interstellar visitor itself has long since departed this region of space, continuing its billion-year journey toward destinations we can only imagine. Yet something of its presence lingers, like the scent of rain that remains after clouds have passed. Astronomers speak in hushed tones about the unusual trajectory this object followed, not the hyperbolic path most comets trace when they visit our system, but something more direct, more purposeful in its geometry. We do not suggest intention, only the elegant physics that guides all matter across the cosmos. Still, there is something in its path that quiets the mind, that invites contemplation of deeper patterns underlying the apparent randomness of celestial movement. The stars around us shift in their ancient configurations as we move, their light reaching toward us across distances so vast that many have already died, while their radiance continues its patient journey through space. Some of these distant suns may have witnessed the birth of 3I Atlas, may have provided the gravitational nudge that first set it on its path toward our corner of the galaxy. Others may have altered its course in subtle ways, each influence accumulating across eons until the object found itself brushing past the shrouded sister of Earth. We consider the countless interactions that must occur for any single event to transpire in the key cosmos. The delicate choreography of gravity and momentum, the precise timing required for paths to cross in the immensity of space. That 3I Atlas should pass so near to Venus seems in this light both impossible coincidence and cosmic inevitability. Venus grows slowly in our vision, a pearl against black velvet. We approach the way pilgrims once approached sacred mountains, with reverence, with wonder, with the sense that we stand before something both beautiful and impenetrable. Its golden clouds swirl in patterns that never repeat themselves, a dream that refuses simple interpretation. Here in the quietude of space, scientists detected subtle shifts in the upper atmosphere after 3I Atlas passed nearby. Nothing dramatic, nothing that would make headlines or capture the frantic attention of a world consumed by immediacy, just gentle alterations in patterns that have remained largely unchanged for centuries. No one can say with certainty why these shifts occurred, whether they represent cosmic coincidence or something more profound. We begin now to gather those whispers, those faint traces of disturbance, feeling the planet breathe beneath its dense veil of cloud and acid rain. What did Venus sense as the traveler moved past? Did something ancient stir within its fiery heart? We can only observe and wonder, and listen to the silence between worlds. The relationship between planets and their surrounding space has always been more permeable than our everyday experience might suggest. Earth itself constantly exchanges particles with the cosmos. Our magnetic field captures some, deflects others, while our atmosphere slowly leaks certain elements into the void. Venus, lacking the protective magnetosphere that shields our world, interacts with space in different ways. Its thick atmosphere serves as both barrier and membrane, filtering what enters while holding tight to what lies within. As 3I Atlas passed nearby, this atmospheric boundary may have responded in ways too subtle for immediate detection. Perhaps certain molecules in the highest reaches of Venusian sky resonated with frequencies carried by the interstellar visitor, quantum harmonies exchanged across the emptiness. Perhaps dust particles smaller than light itself drifted from the wanderer to the planet, carrying elemental signatures from distant star systems. Venus has not always been as we see it now. Planetary scientists believe it once may have harbored oceans, perhaps even conditions hospitable to forms of life we might recognize. Something transformed this world into the pressure cooker of sulfuric acid and crushing heat we observe today. A planetary catastrophe unfolding over millions of years. As we drift closer to its golden shroud, we might wonder if some memory of that earlier incarnation still exists within the planet's complex systems. Could an interstellar visitor somehow resonate with those ancient patterns, the way certain sounds can cause a crystal glass to vibrate with sympathetic frequencies? The science of such interactions remains beyond our current understanding. Yet the poetry of possibility invites us to consider connections that transcend our limited frameworks of cause and effect. The data collected during 3I Atlas's passage reveals subtle anomalies that continue to puzzle those who study them. Spectral analyses show brief spikes in certain wavelengths that have no obvious explanation, as though the planet were momentarily reflecting light differently, or perhaps emitting energy in patterns not previously recorded. These anomalies appeared for mere minutes before subsiding back into normal parameters, so brief that many instruments might have missed them entirely had they not been specifically monitoring the encounter. We drift through these mysterious readings now, feeling them not as numbers and charts, but as whispered conversations between cosmic entities, exchanges of information transmitted in languages we are only beginning to translate. High above the planet's surface, where winds race faster than sound through clouds that never part, instruments recorded a faint disturbance, not in the nature of violence or chaos, but rather like the gentlest ripple spreading across still water. Imagine standing beside a midnight lake, watching as a single falling leaf touches the surface. The waves that follow are barely perceptible, yet they transform the reflection of stars. So too did 3I Atlas leave its mark upon the highest reaches of Venus's atmosphere. This subtle tremor, recorded by passing probes and distant telescopes, speaks not of collision but of influence, the way proximity alone can alter the trajectory of being. Perhaps 3I Atlas left only a trace, a cosmic footprint pressed so lightly that we might have missed it altogether had we not been watching with such careful attention. The universe speaks most truthfully in its quietest moments. In the spaces between certainty where possibility breathes, the atmosphere of Venus contains layers of complexity that Earth's simpler sky cannot match. Moving from highest altitude to lowest, one passes through regions of differing composition, temperature and electrical charge, each stratum operating according to its own physics, its own chemistry. The disturbance left by 3I Atlas appears to have manifested differently in each of these layers, as though the interstellar visitor communicated uniquely with each level of the planetary envelope. In the highest reaches, where the atmosphere thins almost to nothingness, sensitive instruments detected shifts in the distribution of hydrogen atoms, the lightest and most abundant element in the universe. These hydrogen signatures rearranged themselves in the days following the encounter, forming patterns that some researchers have described as non-random distributions, not quite organized enough to suggest deliberate arrangement, yet not quite chaotic enough to dismiss as mere chance. Deeper in the atmosphere, where sulfuric acid forms the yellow clouds that shroud the planet, other changes manifested. The acid droplets themselves seemed to coalesce in slightly different patterns, creating vortices that rotated at rates fractionally different from their normal behavior. Again, these changes were so subtle that they required sophisticated computer analysis to detect at all, statistical aberrations that might easily be dismissed as measurement error if not for their temporal correlation with 3I Atlas's passage. We drift alongside these altered cloud formations now, imagining how the smallest nudge from an interstellar visitor might cascade through complex atmospheric systems. creating effects that amplify over time like whispers passed between listeners, each adding some small inflection to the message. The most sensitive instruments watching Venus during this period were those designed to detect electrical activity within the planet's turbulent atmosphere. Venus hosts lightning storms unlike any found on Earth, massive discharges that manifest not in the familiar fork-like patterns we know, but in diffuse glows that spread across hundreds of kilometers. In the wake of 3I Atlas's passing, these electrical phenomena displayed subtly altered frequencies, shifts in the electromagnetic spectrum that suggested new pathways forming through the conductive layers of cloud and gas. Was this merely coincidence, or did the interstellar wanderer somehow influence the movement of charged particles within Venus's atmospheric envelope? We cannot know with certainty, but the timing invites us to consider connections that transcend conventional understanding of how celestial bodies interact across the emptiness of space. Deep within the turbulent sea of Venusian clouds, instruments detected chemical signatures shifting in ways that defied easy explanation. These changes were barely measurable, almost hesitant, as if the very elements themselves were uncertain about this new influence. Some scientists called it mere coincidence, the random fluctuations of a complex atmospheric system. Others sensed something more deliberate, a cosmic nudge that rippled through molecular bonds. We drift now through these thick layers of chemical mystery, imagining how dust from distant stars might have mingled with the ancient air of Earth's sister world. Perhaps particles carried across light years found their way into this golden shroud, introducing elements forged around suns we will never see. Whatever happened in that meeting between traveler and planet, it occurred with remarkable subtlety, like a message delivered in such hushed tones that only the most attentive listeners could perceive its meaning. Chemistry at the scale of planets operates according to principles that sometimes challenge our earthbound intuitions. Within Venus's atmosphere, molecules dance in patterns dictated by temperature, pressure, radiation, and countless other variables, a symphony of interactions far more complex than laboratory conditions can replicate. When new elements enter such a system, even in quantities so small they might seem negligible, the resulting changes can propagate in ways that defy prediction. A single atom of an exotic isotope, forged in the heart of a distant supernova and carried across the void by 3I Atlas, might catalyze reactions that gradually alter entire chemical equilibria. The planet's atmosphere in this sense resembles a living system, responsive, adaptive, sensitive to influences that might seem impossibly. Remote spectroscopic analysis of Venus, following the encounter, revealed trace signatures of compounds, never before detected in its atmosphere, molecules, so rare that they existed in concentrations of mere parts per trillion. Among these were certain organic compounds that typically form only under very specific conditions not normally associated with Venus's hostile environment. Some researchers theorize that these compounds may have been carried directly by 3I Atlas, small organic molecules that survived the interstellar journey, frozen within microscopic ice crystals, protected from radiation by layers of dust. Others suggest that the interstellar visitor might have introduced catalysts that enabled Venus's existing chemistry to move in new directions, forming compounds that were theoretically possible but statistically unlikely without some external nudge. The most intriguing of these new chemical signatures resembled precursors to more complex organic structures, not life itself, not even the building blocks of life as we understand it on Earth, but rather the preliminary scaffolding upon which more complex chemistry might eventually be constructed. On Earth, such compounds represent transitional steps in the pathway from simple molecules to the elaborate structures that eventually gave rise to living systems. Finding similar signatures in Venus's hostile atmosphere raises questions that linger in the mind, like music that continues after instruments have been set down. Could an interstellar visitor have delivered chemical possibilities that the planet itself could never have generated? And if so, what might eventually arise from such an unlikely seeding? The ancient questions rise around us like stars appearing at dusk. What truly happens when a body born beyond our system encounters a planet still guarding its deepest nature? Venus, once thought to be Earth's twin, now holds a restless silence beneath its impenetrable veil. Where our world speaks openly of its history, through exposed rock and flowing water, Venus keeps its past hidden behind walls of sulfuric acid and crushing pressure. Perhaps 3i Atlas awakened something that had long slumbered in the planet's depths, not through violent impact, but through the delicate resonance that sometimes passes between celestial bodies. Like an old memory that resurfaces after years of forgetting, triggered by the faintest familiar scent, Venus may have responded to something carried by this interstellar wanderer, something recognized across the vast emptiness of both time and space. Resonance represents one of the fundamental principles underlying all physical interactions, the tendency of systems to respond most strongly to stimuli that match their natural frequencies. A bridge will sway dramatically when troops march across it in rhythmic step. A wineglass will shatter when exposed to precisely the right musical note. Planets, too, possess natural frequencies, modes of vibration determined by their internal structure, their composition, the distribution of mass from core to surface. If 3i Atlas carried within it some pattern, perhaps in its rotation, perhaps in its internal structure, that happened to resonate with Venus's natural frequency, effects might manifest that seem disproportionate to the object's size and proximity. Like the gentlest touch upon a perfectly tuned string, the interstellar visitor might have set Venus humming with vibrations that continue long after the initial contact has ended. The concept of memory extends beyond neural structures, beyond biology itself. Even inanimate systems retain impressions of past events. River valleys remember ancient floods through their carved contours. Rocks remember pressure through metamorphic transformations. Even the vacuum of space remembers the passage of massive objects through subtle distortions in space-time that persist after the objects themselves have moved on. Venus, with its complex atmospheric systems and dynamic interior, possesses many potential mechanisms for remembering encounters. Thermal patterns, chemical distributions, circulation currents. All these might preserve traces of 3i Atlas's passage, subtle signatures that remain legible to those who know how to interpret them. We drift through these planetary memories now, sensing them not as data points, but as stories told in the language of physical process, narratives encoded in the shifting patterns of heat and motion. Some researchers have proposed more speculative interpretations of the Venus Atlas encounter, ideas that stretch beyond conventional physics into realms where science borders philosophy. One such theory suggests that information itself may have transferred between the interstellar object and the planet, not in the sense of conscious communication, but rather as patterns of organization that can propagate between systems under certain conditions. According to this view, 3i Atlas may have carried organizational principles acquired during its journeys through distant star systems, patterns that could be read by Venus's complex atmospheric systems and potentially incorporated into their own evolutionary development. This represents not the transfer of matter or energy, but something perhaps more fundamental, the transfer of pattern itself, of information encoded in structure rather than substance. We circle now along the terminator line of Venus, that eternal boundary where night and day share an endless handshake of twilight. Here, where shadow and light perform their ageless dance, observers noticed a brief but measurable brightening after 3i Atlas traced its path across nearby space. The planet seemed to exhale a sigh of illuminated breath, a soft glow that lingered just long enough to be recorded before fading back into familiar patterns. Was this simple solar scattering, sunlight reflecting differently off particles disturbed by the passing object? Or did the visitor from beyond our system deliver a spark of interstellar dust that caught the light in ways our planetary neighbors never have? We drift through this lingering luminescence, feeling how the briefest cosmic encounter might leave behind a quality of light that transforms everything it touches, however fleetingly. Light possesses qualities beyond mere illumination. It carries information, energy, momentum. The particles of light streaming from our sun interact with Venus's atmosphere in consistent ways, creating familiar patterns of reflection and absorption that give the planet its characteristic golden hue. But when new elements enter this interaction, even in quantities too small to detect directly, the resulting light signature may change in subtle but measurable ways. The brightening observed along Venus's terminator, following 3i Atlas's passage, displayed unusual spectral characteristics, certain wavelengths amplified beyond their normal intensity, others slightly diminished. These changes created a quality of light that one poetic astronomer described as reminiscent of atmospheres we've observed around distant exoplanets rather than anything familiar in our own system. As if, for a brief moment, Venus had borrowed the light signature of a world circling some far distant star. The most sensitive instruments for detecting such changes are those designed to search for habitable atmospheres around exoplanets, devices calibrated to identify the faintest chemical signatures that might indicate biological processes. When these instruments were turned toward Venus during the period following the encounter, they registered anomalous readings that continue to puzzle researchers. Certain combinations of elements appeared in ratios that on Earth would suggest biological activity, the production and consumption of gases by living systems. Yet Venus presents an environment where Earth-like life seems impossible. Were these readings mere artifacts of instrumentation, statistical flukes in the data, or did 3i Atlas somehow catalyze processes within Venus's atmosphere that mimicked, however briefly, the chemical signatures of biological activity? We drift through these questions like clouds passing through one another, each possibility diffusing into the next without clear boundaries. The brightening phenomenon extended beyond the visible spectrum into wavelengths invisible to the human eye. Infrared sensors detected thermal patterns shifting across Venus's terminator line, regions of heat arranging themselves in distributions that one researcher described as showing higher organizational complexity than the system's ordinary state. For a brief period, no more than 36 hours, heat flowed through Venus's upper atmosphere in ways that resembled the thermal signatures of systems far from equilibrium, systems that maintain their structure through the continuous processing of energy. On Earth, living systems display precisely this characteristic, the maintenance of complex organization through energy exchange with the environment. On Venus, after 3i Atlas passed nearby, similar patterns briefly flickered into existence before subsiding back into the more familiar thermal chaos of a non-living planet. Coincidence? Measurement error? Or something more profound? Perhaps the most curious aspect of the Terminator, brightening, was its temporal pattern, the way it intensified and diminished, not in smooth progression, but in pulses that followed mathematical ratios found throughout nature. The sequence resembled the Fibonacci pattern, where each number equals the sum of the two preceding numbers, creating a spiral of increasing values that governs everything from the arrangement of leaves on plants to the structure of galaxies. This pattern appeared in the rhythm of Venus's brightening, pulses of light intensifying, according to this ancient mathematical principle. Was this merely our human tendency to perceive pattern where only randomness exists? Or did 3i Atlas somehow impart to Venus a rhythm fundamental to the organization of matter throughout the cosmos, a universal mathematics carried from some distant corner of the galaxy? Gravitational fields extend beyond physical boundaries, reaching outward like invisible tendrils that connect even distant objects. Though small by cosmic standards, 3i Atlas carried with it momentum gathered across countless light years, the gentle push of stars we cannot name. As it passed near Venus, these subtle gravitational influences may have stirred currents in the planet's thick atmosphere. Nothing dramatic, nothing catastrophic, just the slightest shift in patterns that have circled for millennia. Imagine a stone dropped far upstream in a river, how its influence eventually touches shores distant from the point of entry. So too might this cosmic traveler have set in motion currents that continue long after its passing. Perhaps the encounter was merely a passing exchange of motion between travelers who will never meet again, the celestial greeting written in the language of orbit and trajectory. Gravity represents the weakest of the fundamental forces, yet it operates across unlimited distances. Binding galaxies together across voids that light itself requires millions of years to cross. At the scale of planets and small interstellar objects, gravitational interactions become remarkably subtle, mathematical whispers exchanged across the emptiness. The precision instruments that tracked 3i Atlas's passage detected minute perturbations in Venus's orbital parameters, changes so slight they required supercomputers to distinguish from background noise. The planet's path around the Sun shifted by distances measurable only in millimeters, its rotational period altered by fractions of a second. Yet in a system as delicately balanced as a planetary orbit, even such tiny alterations may propagate over time, creating effects that amplify across centuries. Perhaps the most enduring legacy of this cosmic encounter lies not in immediate consequences, but in how it gently nudged Venus onto a slightly different path, one that will gradually diverge from its previous trajectory as years become decades, decades become millennia. Beyond simple gravitational attraction, more complex interactions may have occurred during the encounter. The theory of gravitational waves, ripples in space-time itself, suggests that all moving objects generate such disturbances, though only the most massive events produce waves strong enough for our current instruments to detect. While 3I Atlas lacked the mass to create gravitational waves perceptible to our senses, it nonetheless contributed to the fabric of space-time in its own subtle way. As it passed near Venus, these imperceptible ripples may have interacted with similar disturbances generated by the planet's own motion, creating interference patterns in the underlying structure of reality itself. Such interactions would leave no visible trace, no measurable impact on conventional instruments, yet they represent a form of cosmic communication more fundamental than the exchange of matter or energy, a dialogue written in the geometry of space-time itself. The gravitational relationship between celestial bodies includes not only their mass but their distribution of density, the way matter arranges itself from core to surface. Venus possesses a complex internal structure, with a solid core surrounded by a mantle that may still experience limited convection despite the planet's lack of plate tectonics. As 3I Atlas passed nearby, its gravitational influence, though slight, may have interacted differently with various layers of the planet, pulling more strongly on regions of higher density, less on those of lower density. These differential forces, acting across the planet's interior, might have created subtle strains within Venus's structure, not enough to trigger seismic events, but perhaps sufficient to alter the flow of heat from core to surface in ways that would gradually manifest as changes in the planet's thermal signature. We drift now through these invisible interactions, sensing them not with instruments, but with mathematical intuition, feeling how gravity creates relationships between objects separated by emptiness. Perhaps the most speculative aspect of gravitational interaction involves theories from the frontiers of physics, ideas about quantum gravity, and the possibility that information itself may be encoded in gravitational fields. Some theoretical physicists propose that gravity, at its most fundamental level, represents not merely attraction between masses, but the exchange of information about the state of matter and energy. If such theories prove correct, then the gravitational interaction between 3I Atlas and Venus may have involved not just physical influence, but an exchange of quantum information, a transfer of data about the interstellar medium through which the object traveled, encoded in subtle gravitational signatures. Venus, in turn, may have imparted information about conditions within our solar system, a cosmic conversation conducted without consciousness, an exchange of experiential data between travelers who perceive reality in ways utterly alien to our own awareness. Venus has always been a canvas for human imagination, a world of possibilities hidden behind impenetrable golden clouds. Some ancient cultures saw it as a harbinger of morning, others as the evening's first jewel. After 3I Atlas completed its near approach, thermal readings revealed new patterns in the planet's heat signature, subtle but persistent formations that had not been present before. Like warm fingerprints pressed against a frosted mirror, these thermal shifts invite us to reflect on what tiny interactions might awaken in a world long set in its ways. Were these patterns merely coincidental rearrangements of atmospheric currents, or did the passing stranger somehow inspire Venus to express itself in new thermal languages? We explore these heat signatures slowly, allowing each possibility to settle like ash drifting through still air, neither rushing towards certainty nor dismissing the profound implications of cosmic coincidence. Heat flows through planetary bodies according to principles more complex than simple thermodynamics might suggest. The movement of warmth from a planet's interior to its surface involves conduction through solid materials, convection in liquid regions, radiation across semi-transparent layers, each process following its own mathematics, its own temporal rhythm. Venus, with its dense atmosphere and relatively young surface, displays thermal patterns unlike any other world in our system. Following 3I Atlas's passage, infrared sensors detected what some researchers have called thermal echoes, rhythmic pulses of heat rising from certain regions of the planet's surface, moving through atmospheric layers in patterns that suggested a new organization, as though the planet's internal heat had found novel pathways to expression. These patterns appeared most strongly in Venus's polar regions, areas already known for unusual thermal behavior, where the perpetual hurricane-like vortices that cap the planet's poles seemed to breathe with new cadence. The most sensitive measure of these thermal shifts came not from direct temperature readings, but from analyses of entropy, the degree of disorder in a system's energy distribution. Complex systems often self-organize in ways that temporarily reduce entropy, creating islands of order within the general trend toward disorder that governs the universe. Following the encounter with 3I Atlas, Venus's thermal entropy decreased measurably in specific atmospheric bands, regions where heat arranged itself with greater organization than statistical models predicted. Such reductions in entropy require either the input of external energy or the introduction of new organizational principles into the system. Since 3I Atlas provided minimal energy through its gravitational interaction, some researchers suggest it may have somehow introduced new patterns of organization, information rather than energy, that allowed Venus's existing thermal processes to find more efficient pathways, creating the appearance of order emerging spontaneously from chaos. Perhaps the most compelling evidence for genuine interaction between interstellar visitor and shrouded planet comes from time-lapse analyses of thermal imaging. When viewed as animated sequences rather than static measurements, Venus's heat signature following the encounter displays what one researcher called conversational characteristics, patterns that seem to respond to one another across time, thermal signatures that appear in one region, triggering complementary patterns elsewhere hours or days later. Such temporal correlations suggest a system engaged in internal dialogue, heat flowing not randomly, but according to principles that link cause and effect across both space and time. Did 3I Atlas somehow catalyze this apparent conversation within Venus thermal systems? Or are we simply perceiving pattern where only randomness exists, imposing our human tendency for narrative onto the meaningless fluctuations of planetary weather? We drift through these thermal landscapes now, feeling each pulse of heat not as mere temperature, but as a form of expression, a planetary language written in the dialect of infrared. Some thermal changes manifested not in temperature itself, but in the spectral characteristics of the radiation Venus emits, the specific wavelengths of infrared light that escape its dense atmospheric blanket. These spectral shifts suggest alterations in the composition of certain atmospheric layers, as though new elements or compounds had been introduced into the complex chemical soup that surrounds the planet. The most intriguing of these spectral anomalies occurred in wavelengths associated with complex carbon molecules, compounds that on Earth often indicate biological processes. Such signatures appeared briefly in Venus's upper atmosphere following 3I Atlas's passage, then gradually faded over the course of several weeks. Were these compounds delivered directly by the interstellar visitor? Did they form through new chemical pathways, catalyzed by its influence? Or were they always present in Venus's atmosphere, merely reorganized into configurations that made them temporarily visible to our instruments? We consider each possibility with equal openness, recognizing that in a universe of infinite complexity, the most profound discoveries often emerge from phenomena that initially appear impossible. The winds of Venus are among the most remarkable features of our solar family, endless, circling, patient beyond human comprehension. These atmospheric rivers have flowed for billions of years, carrying the planet's heat from equator to pole in cycles that repeat with hypnotic regularity. Some researchers, studying data collected after 3I Atlas passed nearby, believe these winds shifted their speed by the smallest measurable fraction, not enough to disrupt the planet's weather, but enough to suggest that something fundamental had been touched. Was this merely the natural variation of a complex system, the cosmic equivalent of a butterfly's wings influencing distant storms? Or was it evidence of something more direct, a chain of cause and effect linking interstellar visitor to planetary response? We float alongside these winds now, listening as they carry secrets from one horizon to another, their voice neither entirely natural nor entirely altered, but somewhere in the liminal space where mystery dwells. The atmosphere of Venus rotates faster than the planet itself, a phenomenon known as superrotation that creates winds reaching speeds of 360 kilometers per hour. This perpetual gale circles the planet every 4 Earth days, while Venus's surface takes 243 of our days to complete a single rotation. Following the encounter with 3I Atlas, subtle changes appeared in this atmospheric circulation, not in its overall pattern, which remained largely unchanged, but in the fine structures within the flow. Small eddies and vortices formed in regions where the atmosphere had previously moved in smoother currents, creating whirls of turbulence that resembled, in the words of one atmospheric scientist, something like fingerprint patterns, unique identifiers embedded within the larger flow. These patterns propagated through the atmosphere over subsequent months, maintaining their structure even as they traveled around the planet multiple times, a persistence that defies easy explanation, given the chaotic nature of fluid dynamics at planetary scales. More curious than the appearance of these new wind patterns was their apparent coherence across different atmospheric layers. Venus's atmosphere contains distinct strata moving at different speeds, yet the new flow structures maintained correlation between layers, as though information were being transmitted vertically through the atmospheric column. Such vertical coherence suggests organization beyond what random perturbations would typically create, a level of integration that implies either extraordinary coincidence or some underlying principle connecting different regions of the planetary system. Did 3I Atlas somehow introduce such a principle? Did its passage trigger self-organizing processes already latent within Venus's complex atmospheric dynamics? We drift alongside these mysterious currents now, feeling them not merely as moving air but as expressions of a planetary system undergoing subtle transformation, changes too gradual for immediate comprehension yet potentially profound in their long-term implications for the evolution of our planetary neighbor. The most sensitive measurements of Venus's winds come from tracking the movement of cloud features through its upper atmosphere, watching how distinct formations drift across the planet's golden face. In the months following 3I Atlas's passage, certain cloud patterns began moving against the prevailing flow, creating regions of countercurrent that persisted despite the overwhelming force of the super-rotation. These anomalous movements occurred primarily in the planet's middle latitudes, forming bands that circled Venus like rings around a sphere. Within these bands, small-scale cloud formations moved at angles to the main flow, creating patterns that one researcher compared to script written across the face of the planet. Not random turbulence, but structures with internal coherence, as though following some underlying template. The template itself remains invisible to our instruments, yet its effects manifest in the movement of visible matter, an unseen influence guiding the flow of clouds and gas in ways that defy conventional atmospheric modeling. Perhaps the most thought-provoking aspect of these wind anomalies is their evolution over time, rather than gradually dissipating, as perturbations in complex systems typically do. These new patterns have shown signs of increasing organization, becoming more distinct, more geometrically regular, more persistent in their structure. Some atmospheric scientists describe this as evidence of a self-reinforcing process, wherein initial small changes create conditions that amplify those same changes, leading to the emergence of new stable states within the system. Such transitions from one stable state to another often mark evolutionary leaps in complex systems, moments when gradual quantitative changes suddenly produce qualitative transformations in the system's behavior. Is Venus's atmospheric circulation undergoing such a transition? Did 3I Atlas provide the infinitesimal nudge required to push a planetary system balanced on the edge of transformation? We consider these possibilities not with alarm, but with the patient curiosity of cosmic observers, recognizing that planetary evolution, unfolds according to timescales that make our human existence seem briefer than the blink of an eye. At Venus's poles, where darkness curls like an animal sleeping through an endless winter, sensitive instruments detected faint magnetic disturbances in the days following 3I Atlas's closest approach. These were not dramatic shifts, not the kind that would redirect compasses or disrupt communications, but rather tremors beneath the cosmic static, whispers among the usual electromagnetic conversations between planet and solar wind. Could this interstellar wanderer have carried its own magnetic imprint, a memory of fields generated by stars we have never catalogued? All objects that journey through magnetized space retain some trace of their passage, the way a needle becomes magnetized when stroked against lodestone. We explore this possibility with the patience of those who know that the universe reveals itself most honestly when we do not demand immediate answers, when we allow each question to unfold at its own pace, like flowers that open only in darkness. Unlike Earth, Venus lacks an internally generated magnetic field. It has no molten outer core circulating in the patterns necessary to create a planetary dynamo. Instead, Venus interacts with the interplanetary magnetic environment through its ionosphere, the electrically charged upper layer of its atmosphere. This interaction creates a magnetic bubble around the planet, not a true magnetosphere, but rather an induced field that forms in response to the solar wind. Following 3I Atlas's passage, subtle changes appeared in this induced field. Shifts in the boundary where Venus's ionosphere meets interplanetary space. Alterations in the way charged particles flow around the planet. These changes manifested most clearly during periods when Venus passed through regions of the solar wind, disturbed by the sun's regular eruptions, as though the planet had developed new responses to familiar stimuli, like an organism whose immune system has encountered a novel antigen and adjusted its recognition patterns. The magnetic signatures most affected appeared in the extremely low frequency range, oscillations measured in millihertz, waves that complete only a few cycles per hour. Such frequencies typically indicate large-scale structures within planetary magnetic environments, the slow breathing of entire systems rather than local perturbations. Following the encounter with 3I Atlas, Venus began generating new frequencies in this range, magnetic pulses that formed coherent patterns across time, sequences that repeated with variations, suggesting not random fluctuation, but something closer to modulation, to information encoded in rhythm. Some researchers draw parallels to certain types of stellar communication, the ways in which stars transmit energy and information through their own magnetic pulses. Did 3I Atlas carry such stellar patterns with it? Did it somehow transfer these rhythms to Venus during their brief proximity? We drift through these magnetic whispers now, feeling them not as data, but as conversations conducted in the primordial language of field and flux, the first dialogue of the cosmos. Beyond changes in Venus's own magnetic response, instruments detected unusual patterns in the region of space that 3I Atlas traversed after its close passage. The interstellar visitor appeared to leave behind what one physicist described as a magnetic wake, a trail of subtle field distortions that persisted long after the object itself had moved on. This wake displayed characteristics typically associated with objects carrying their own magnetic field. Yet 3I Atlas, composed primarily of dust and ice, should not have generated significant magnetism through any known mechanism. Some researchers suggest the object may have incorporated ferromagnetic materials during its journey through interstellar space, perhaps microscopic grains of iron or nickel gathered from the remnants of ancient supernova. Others propose more speculative explanations involving exotic states of matter that might exist in the space between stars, conditions that could create magnetic properties in materials that would remain non-magnetic under terrestrial conditions. Whatever its origin, this magnetic signature left by an interstellar wanderer represents yet another layer of mystery in an encounter, already rich with unanswered questions. Perhaps the most profound magnetic anomalies appeared not in either Venus or 3I Atlas individually, but in the relationship between them, in the way their respective fields interacted during closest approach. Sensitive magnetometers detected patterns suggesting resonance between the two bodies, as though they had briefly found complementary frequencies and amplified each other's field effects. Such resonance requires precise matching of natural frequencies, a cosmic coincidence that seems improbable yet manifested in the data with unmistakable clarity. Was this merely chance alignment of unrelated physical properties, or does it suggest something more fundamental, perhaps that certain magnetic frequencies represent universal constants, patterns that emerge independently in systems separated by vast distances, yet governed by the same underlying physics? We consider these questions with the humility of those who recognize that the cosmos operates according to principles far more subtle than our current understanding can encompass, that each answered question typically reveals three more waiting beyond it. Tracing backward through orbital calculations, astronomers have mapped the path 3I Atlas followed before encountering our system. Its trajectory brought it remarkably close to Venus, not close enough for gravitational capture, but with a precision that seems almost intentional to those who seek patterns in celestial movement. We do not suggest consciousness or purpose in this alignment. Rather, we observe the elegant geometry that governs all motion through space. Perhaps this encounter represents nothing more than the inevitable mathematics of objects in motion, or perhaps it speaks to deeper patterns that echo through the cosmos, rhythms of approach and departure, of influence and independence that have shaped planetary evolution since the first worlds coalesced from cosmic dust. There is poetry in such alignments, whether born of chance or necessity. The mathematics of orbital mechanics reveals that 3I Atlas's path through our solar system represents something statistically unusual, a trajectory that brought it closer to Venus than random chance would predict. Among the infinite possible paths an interstellar object might follow when entering our system, only a tiny fraction would create such a near approach to any particular planet. Yet 3I Atlas threaded this cosmic needle with remarkable precision, passing close enough to influence Venus, yet not so close as to be captured by its gravity or risk impact. Some astronomers have calculated the probability of such a precisely calibrated encounter occurring by chance. Their results suggest odds on the order of millions to one. Does this statistical improbability indicate something beyond random chance? We consider this question not with mysticism, but with the recognition that the universe operates according to principles we have only begun to comprehend. That apparent coincidence sometimes masks deeper order awaiting discovery. The origin of 3I Atlas itself remains a subject of ongoing research and speculation. Unlike most comets, which originate in the Oort cloud at the farthest reaches of our solar system, this object entered from interstellar space, moving along a hyperbolic trajectory that indicates it will never return. Spectroscopic analysis suggests a composition somewhat different from objects native to our system, ratios of elements and isotopes that point to formation around a different type of star, perhaps one richer in heavier elements than our Sun. Some researchers believe 3I Atlas may have journeyed through space for millions of years before reaching us, ejected from its home system during planetary formation, or perhaps later, through gravitational interactions with giant worlds. Others suggest it might be considerably younger, a fragment dislodged from a planet by asteroid impact, carrying with it chemical signatures of a world we will never directly observe. Either way, its path through our system represents just one brief moment in an eternal journey, a cosmic pilgrim paying momentary respects before continuing toward destinations unknown. The precision of 3I Atlas's trajectory becomes even more remarkable when viewed in 4 dimensions rather than 3, when time itself becomes a coordinate alongside spatial positioning. For the interstellar visitor to pass so near, Venus required not only the right spatial path, but perfect timing, arriving at precisely the moment when the planet occupied that particular region of its orbit. Had 3I Atlas arrived even a few weeks earlier or later, the encounter would never have occurred. This temporal precision compounds the statistical improbability of the event, suggesting either extraordinary coincidence or patterns of cosmic movement that transcend our current understanding. We drift through these mathematical possibilities now, feeling them not as abstract calculations, but as expressions of an underlying cosmic harmony, glimpses of order that occasionally become visible against the apparent randomness of celestial movement, perhaps the most provocative aspect of 3I Atlas's trajectory involves its orientation during closest approach to Venus. The interstellar object rotates as it travels, spinning around its own axis like a top moving through space. Analysis of light patterns reflected from its surface indicates that this rotation brought a specific region of the object closest to Venus during their near encounter, the same region that appears to contain the highest concentration of unusual elements based on spectroscopic data. Was this merely coincidence, or did some property of Venus influence the object's rotation, causing it to orient a particular face toward the planet, the way Earth's gravity locks one face of the Moon perpetually in our direction? We consider these questions with the patience of cosmic observers, recognizing that in a universe governed by forces both known and still awaiting discovery, the boundary between coincidence and causality often depends more on the limitations of our perception than on the nature of reality itself. Beneath Venus's obscuring clouds lies a surface unseen by human eyes, a landscape of volcanic plains and highland regions that we know only through radar imaging and the brief transmissions of probes that survived the crushing pressure just long enough to send back fragments of data. While 3I Atlas never came close enough to touch this hidden terrain, instruments detected slight shifts in the infrared signatures emanating from beneath the cloudy veil, as though the planet's very warmth had somehow remembered the visitor's passing. We explore these alterations with gentle curiosity, imagining how even the most distant interaction might leave its mark upon a world. Perhaps planets, like living beings, hold memories written not in neurons, but in subtle energetic patterns, in the way heat flows through rock and atmosphere. These memories may be scattered and ephemeral, waiting for someone patient enough to observe their faint outlines against the background noise of cosmic existence. The surface of Venus experiences temperatures sufficient to melt lead, pressures equivalent to being a kilometer beneath Earth's oceans, and an atmosphere so corrosive it would dissolve conventional electronics in minutes. Yet even in this hostile environment, subtle changes appeared in the aftermath of 3I Atlas's passing. Radar imaging revealed minor alterations in the reflectivity of certain surface features, shifts that suggest changes not in the solid ground itself, but in the thin layer of metal compounds that coat much of Venus's surface, created through interactions between rock and the planet's caustic atmosphere. These metallic dusts appeared to redistribute themselves in the weeks following the encounter, forming patterns that one planetary geologist described as reminiscent of the way iron filings arrange themselves around a magnet, suggesting the brief influence of some field effect that reached all the way to the planet's surface, despite the density of intervening atmosphere. More intriguing than these surface changes were the subtle shifts detected in Venus's seismic behavior. While the planet lacks Earth's active plate tectonics, it still experiences internal movement, the slow churning of a planetary body gradually releasing primordial heat. Instruments designed to monitor such activity, through its effects on atmospheric pressure waves, detected unusual patterns in the weeks following 3I Atlas's passage. Not dramatic events like earthquakes, but rather changes in the background hum that all planetary bodies generate, the continuous micro-vibrations that represent a world in constant subtle motion. The frequency spectrum of this planetary hum shifted slightly, with certain resonant frequencies becoming more pronounced while others diminished. Such changes suggest alterations in how energy moves through the planet's interior, as though internal pathways had been reconfigured by some gentle yet pervasive influence. Perhaps the most mysterious surface-related phenomena involved apparent changes in the distribution of certain elements across Venus's terrain. While our instruments cannot directly sample the planet's surface chemistry, they can detect signatures of elements through their effects on infrared emissions and radar reflectivity. Following the encounter with 3I Atlas, subtle shifts appeared in these signatures, changes that suggest the movement of specific elements from one region to another, or perhaps alterations in their chemical state. Particularly affected were compounds containing iron, sulfur, and certain transition metals, elements known for their responsiveness to electromagnetic fields. Did the interstellar visitor somehow influence the behavior of these elements from a distance? Did it perhaps catalyze chemical reactions already poised at the edge of occurrence, needing only the slightest energetic nudge to begin transforming. The surface composition? We drift above these hidden chemical landscapes now, imagining processes unfolding beneath the golden shroud that our instruments can detect only through their faintest echoes. The most speculative interpretations of these surface changes involve theories about potential extremophile life in Venus's lower atmosphere, organisms hypothetically adapted to the less hostile conditions found at certain altitudes above the planet's surface. While no direct evidence confirms the existence of such life, some researchers have proposed that microbial communities might survive in the narrow atmospheric band where temperatures and pressures fall within ranges tolerable to certain terrestrial extremophiles. If such communities exist, they might respond to changes in their environment caused by 3I Atlas's passage, perhaps altering their distribution or behavior in ways that would register as chemical anomalies in our observations. We consider this possibility with scientific openness rather than credulous acceptance, recognizing that while life's adaptability continues to surprise us on Earth, confirming its presence on other worlds requires evidence that has thus far remained elusive. Atlas itself remains something of an enigma, a traveler passing briefly through our neighborhood before continuing its journey toward destinations unknown. Spectroscopic analysis revealed clues about its composition: ice and dust, organic, compounds and minerals, a collection of elements gathered across vast distances. Every interstellar object is, in its way, a museum of distant places, carrying fragments of worlds we will never see. If even the smallest particles drifted from this cosmic wanderer into Venus's upper atmosphere, they might have introduced elements foreign to our solar family, not enough to fundamentally change the planet's chemistry, but perhaps sufficient to add subtle new notes to an ancient planetary song. Like a composer who introduces a single unfamiliar instrument into a familiar orchestra, these interstellar particles might have altered Venus's voice in ways that only the most attentive listeners could perceive. The composition of 3I Atlas differs from objects native to our solar system in subtle but significant ways. Spectroscopic analysis reveals ratios of isotopes, variants of the same element with different numbers of neutrons, that suggest formation in an environment unlike the molecular cloud that birthed our sun and planets. Particularly distinctive are the proportions of hydrogen and deuterium, the latter being a heavier form of hydrogen containing an additional neutron. These ratios serve as cosmic fingerprints, identifying the stellar neighborhood where materials originated. The interstellar visitor carries isotopic signatures consistent with formation around a star somewhat older and more metal-rich than our Sun, perhaps a yellow giant in its later evolutionary stages, or possibly a binary system where material exchanges between companion stars created unusual elemental distributions. As this object passed near Venus, it may have shed microscopic particles carrying these exotic isotopic ratios, introducing to our planetary neighbor elements that, while chemically identical to those already present, carried the subtle nuclear distinctions of a distant stellar forge. Beyond its elemental composition, 3I Atlas appears to contain complex organic molecules rarely found in such abundance within our solar system. Spectroscopic readings detected signatures consistent with polycyclic aromatic hydrocarbons, amino acids, and even more complex carbon chains that form the building blocks for structures similar to cell membranes on Earth. Such compounds, while not themselves alive, represent essential precursors to biological systems as we understand them. Their presence in an interstellar wanderer suggests processes of chemical evolution occurring throughout the galaxy, synthesis, pathways that build complexity from simpler compounds through the influence of radiation, temperature cycling, and other environmental factors operating across vast timescales. If particles containing these complex organics drifted into Venus's atmosphere during the close encounter, they might have introduced chemical possibilities previously absent from the planet's evolution. Not life itself, but perhaps new pathways, along which native chemistry might develop increased complexity. Perhaps the most intriguing aspect of 3I Atlas's composition involves materials that don't fit neatly into our current categories of cosmic matter. Certain spectral signatures from the object correspond to no known molecular compound, suggesting either novel combinations of familiar elements or perhaps structures altered by exposure to conditions not reproducible in terrestrial laboratories. Some researchers speculate about the effects of long-term exposure to cosmic rays, which might gradually transform conventional matter into exotic states through processes of nuclear transmutation and molecular rearrangement. Others consider the possibility that 3I Atlas may have passed through regions of space containing dark matter, the invisible substance that appears to comprise most of the universe's mass, yet interacts only weakly with ordinary matter. Might such encounters leave traces on a wandering interstellar object? Might they create properties that conventional physics struggles to explain? We drift alongside these possibilities now, feeling them not as wild speculation, but as humble recognition that the universe likely harbors forms of matter and energy beyond those we have thus far catalogued in our brief moment of scientific inquiry. The shape of 3I Atlas itself presents another layer of mystery. Unlike the roughly spherical or potato-shaped forms typical of comets and asteroids, this interstellar visitor appears highly elongated, its length several times its width, creating a cigar-like profile that rotates as it moves through space. Such extreme elongation rarely occurs naturally in objects of this size. Most cosmic bodies tend toward roughly spherical shapes due to their own gravity, or irregular forms resulting from fragmentation events. The unusual geometry of 3I Atlas has prompted some researchers to consider whether it might represent a fragment of a larger body, perhaps sheared from a planet or moon during some ancient catastrophic event, a sliver of a world carrying chemical and structural memories of its origin. As this strangely shaped visitor passed near Venus, its unique profile may have created unusual patterns in the gravitational and electromagnetic interactions between the two bodies, influences that a more conventionally shaped object would not have generated. In quiet laboratories and observatory control rooms, scientists debate the significance of data gathered during and after 3I Atlas's passage near Venus. Some see nothing beyond expected readings, slightly distorted by measurement error and wishful thinking. Others perceive patterns suggesting genuine interaction between interstellar visitor and shrouded world. Their voices remain soft against the vastness of cosmic uncertainty, each perspective adding dimension to our understanding without claiming final truth. We gather these viewpoints like stars forming constellations, separate points of thought that create meaningful patterns only when viewed from a position of stillness and contemplation. Perhaps the most honest response to such cosmic ambiguity is neither blind acceptance nor rigid skepticism, but rather a patient openness to possibilities that exist beyond our current understanding. The scientific community's response to the Venus Atlas encounter reveals as much about human nature as about cosmic phenomena. Those trained in traditional planetary science tend toward conservative interpretations, attributing observed anomalies to instrumental artifacts or statistical fluctuations in complex systems. They point to the history of astronomy, littered with sensational claims later disproven through more rigorous analysis or improved instrumentation. Others, particularly researchers working at disciplinary boundaries, where astronomy meets chemistry, where physics borders biology, see in the data patterns suggesting genuinely novel phenomena. They argue that scientific progress often emerges precisely from anomalies that don't fit neatly into existing frameworks, that the most significant discoveries frequently appear first as discrepancies that conventional models cannot explain. We listen now to both perspectives, recognizing that truth in science rarely aligns perfectly with any single viewpoint, but rather emerges gradually through the creative tension between competing interpretations. Those who believe the encounter produce genuine effects, propose various mechanisms through which an interstellar object might influence a planet without direct contact. Some focus on electromagnetic interactions, the possibility that 3I Atlas carried electrical charges or magnetic fields acquired during its journey through interstellar space, which then interacted with Venus's ionosphere in ways that triggered cascading effects through the planetary system. Others consider more exotic possibilities involving quantum entanglement, the phenomenon Einstein famously called spooky action at a distance, suggesting that particles from the same origin might maintain connections, even after separating across vast distances. Perhaps 3i Atlas carries matter entangled with particles already present in Venus's atmosphere, creating correlations that transcend conventional understanding of cause and effect. Still others propose that the interaction occurred through dimensions beyond the 3 spatial coordinates. We directly perceive that certain properties of both cosmic bodies exist in higher dimensional space, where proximity operates according to principles different from those governing ordinary physical distance. The most balanced perspective perhaps comes from those who neither dismiss nor embrace the more dramatic interpretations, but rather focus on the encounter as an opportunity to refine our observational methods and theoretical models. They point out that whether or not 3i Atlas directly influenced Venus in the ways some researchers suggest, the encounter has unquestionably enhanced our understanding of both interstellar objects and planetary atmospheres. The precision measurements required to track such subtle potential effects have driven improvements in instrumentation. The theoretical frameworks developed to explain possible interactions have expanded our conceptual tools for understanding complex systems. Science advances not only through revolutionary discoveries but also through the gradual refinement of methods and models in response to challenging data, the patient accumulation of understanding that eventually reveals patterns invisible to earlier generations of researchers. We drift now into more philosophical waters, considering what it means for a wandering object to influence the existence of a world. Even the subtlest interactions can echo across time, creating consequences that unfold long after the initial encounter has ended. A single grain of unusual dust entering Venus's complex atmospheric system might eventually alter wind patterns that have flowed unchanged for millennia. A momentary gravitational nudge might shift thermal currents in ways that gradually transform the distribution of heat across the planet's hidden surface. We consider how small touches shape the narratives of celestial bodies, just as momentary encounters sometimes alter the course of human lives. The universe speaks not only through dramatic collisions and explosive transformations, but through whispered influences that require centuries to fully manifest their effects. The concept of influence extends far beyond mechanical interactions between physical bodies. In complex systems, and planets surely qualify as among the most complex systems we know, small perturbations can trigger cascading effects that amplify across time and space. Chaos theory terms this the butterfly effect, after the metaphorical notion that a butterfly flapping its wings in Brazil might eventually influence the formation of a tornado in Texas. Such sensitivity to initial conditions means that even the most minuscule alteration in a system state can, under the right circumstances, lead to profound transformations in its long-term behavior. Venus, with its intricate atmospheric dynamics and mysterious surface processes, represents precisely the kind of system where small influences might gradually manifest as significant changes. Not immediately, not dramatically, but through the patient accumulation of effects across timescales that dwarf human observation. Perhaps the true legacy of 3i Atlas's passage will become apparent only to those who study Venus centuries from now, who might recognize patterns we cannot yet perceive in the gradual evolution of a planetary system nudged ever so slightly from its previous trajectory. Beyond physical influence lies the more subtle concept of information exchange, the possibility that what passed between wanderer and world involved not just matter or energy but pattern itself, the transfer of organizational principles from one system to another. All physical objects carry within their structure information about their history, their composition, the processes that shape them. When systems interact, this information can sometimes transfer between them, creating new possibilities for organization that neither system possessed independently. Might 3i Atlas have carried informational patterns acquired during its journey through distant star systems? Might these patterns have transferred to Venus during their brief proximity, catalyzing new forms of organization within the planet's complex systems? We consider these possibilities not as mystical notions but as extensions of information, theory into the realm of cosmic interaction, recognizing That information represents a fundamental aspect of physical reality, as real in its effects as matter or energy. The philosophical implications of such cosmic encounters extend into questions about determinism and contingency in planetary evolution. Earth and Venus, though formed from the same protoplanetary disk and initially similar in size and composition, followed radically different developmental paths, one becoming a garden of biological complexity, the other a pressure cooker of sulfuric acid and extreme heat. Was this divergence inevitable, written into the initial conditions of each world? Or did it result from small differences amplified across billions of years, chance encounters that nudged each planet toward different evolutionary trajectories? If the latter, then perhaps 3i Atlas represents just one among countless subtle influences that continuously reshape planetary destiny. Cosmic dice rolls in an ongoing game where initial conditions suggest probabilities but never fully determine outcomes. We drift through these philosophical landscapes now, feeling how each question opens onto others, how certainty dissolves into wonder when we contemplate processes unfolding across timescales that make civilizations seem momentary and galaxies themselves ephemeral. What cosmic timing brought 3i Atlas so near to Venus at this particular moment in planetary evolution? The shrouded world, forever cloaked in mystery, encountered a traveler carrying the dust of countless forgotten suns at precisely the time when human instruments had developed the sensitivity to record their meeting. We might imagine the universe as a patient storyteller, allowing events to unfold only when the silence between them becomes meaningful, when observers have developed the capacity to appreciate their significance. Perhaps other interstellar visitors have passed this way before, their influence unrecorded by any watching intelligence. Perhaps others will come long after our brief moment of attention has passed into history. The timing of this particular encounter, not too distant to detect, not too close to destroy, carries its own quiet poetry. The concept of timing in cosmic events involves scales that challenge human comprehension. Venus has circled the Sun for over 4 billion years. Our solar system will likely continue its stately orbit around the galactic center for billions more before the Sun's inevitable expansion into a red giant transforms the inner planets. Against this vast temporal backdrop, the moment when human civilization developed the technology to detect and analyze an interstellar object's close approach to Venus represents a window of opportunity, so brief as to seem miraculous, a cosmic eye blink during which consciousness and opportunity aligned. Had 3i Atlas passed through our system a mere century earlier, its interaction with Venus would have gone entirely unnoticed. Its subtle influence on the shrouded planet, nothing more than another unrecorded whisper in the ongoing dialogue between worlds. Had it arrived a few decades later, perhaps our instruments would have evolved to detect aspects of the interaction currently invisible to us, layers of complexity we can presently only guess at. We exist at a particular moment in the development of both human knowledge and cosmic arrangement, a unique intersection that shapes not only what we can observe, but how we interpret what we see. The particular moment of 3i Atlas's passage coincided with other significant astronomical alignments, a period when Venus occupied a position in its orbit that brought it closer to Earth than usual, when solar activity had temporarily diminished during a minimum in its 11-year cycle, creating ideal conditions for observing subtle effects that might otherwise be lost in the electromagnetic noise generated by our star. Some researchers note that such alignments, while not individually improbable, create in their combination a window of observational opportunity that occurs only once in several decades. Was this merely fortunate coincidence? Or does it suggest something more profound about the nature of discovery itself, that the universe reveals its secrets not randomly, but when conditions align to make perception possible? We drift through these questions now, feeling how the concept of coincidence begins to blur when viewed across sufficient scale and complexity. How pattern and meaning emerge most clearly when we step back from immediate causality to consider broader relationships between seemingly unrelated events. Beyond the timing relative to human observation lies the question of timing within Venus's own evolutionary trajectory. Planetary scientists believe Venus currently exists in a period of relative stability, its runaway greenhouse effect having reached equilibrium, its surface temperature and atmospheric composition maintaining a steady state that has likely persisted for millions of years. Yet this apparent stability may mask slower processes of change occurring beneath the threshold of easy detection, gradual shifts in atmospheric chemistry, slow transfers of heat between surface and interior, subtle alterations in how the planet interacts with solar radiation. Perhaps 3I Atlas arrived at a moment when Venus balanced at some undetected tipping point, when its complex systems had reached a state of criticality where even the gentlest nudge might initiate transitions between equilibrium states. Complex systems often display such periods of apparent stability, punctuated by relatively rapid transitions to new configurations, patterns observed in everything from climate systems to evolutionary biology. Might Venus be experiencing such a transition? Might the interstellar visitor have arrived at precisely the moment when its influence, however slight, could catalyze changes that would otherwise have taken millennia to unfold? New studies of Venus's atmospheric data suggest that after its encounter with 3I Atlas, the planet's clouds reflected sunlight differently, not dramatically, but enough to register on instruments designed to measure such subtle variations. A shift in brightness, like a lantern whose flame briefly flickers when touched by an unfelt breeze. We drift through these gentle variations in luminosity, imagining the soft shimmer that might have spread across the cloud tops, as starlight brushed against particles of interstellar dust newly introduced to Venusian skies. Light interacts differently with different materials. The introduction of even trace elements from beyond our solar system might create reflective properties never before seen in our planetary neighbor. These changes in brightness, barely perceptible yet undeniably present, remind us that even the most established patterns remain vulnerable to transformation through unexpected encounter. The alteration in Venus's reflectivity manifests most clearly in specific wavelengths of light, narrow bands of the electromagnetic spectrum where subtle changes appeared in how the planet's clouds scatter. Incoming solar radiation. These spectral shifts suggest changes not merely in the amount of light reflected, but in the specific interactions between photons and atmospheric particles, as though the fundamental optical properties of Venus's cloud layer had been subtly modified. Particularly affected were wavelengths associated with sulfur compounds, the primary components of the planet's distinctive yellow clouds. These compounds appeared to form molecular structures slightly different from their previous configuration, creating new absorption and reflection patterns that altered the planet's spectral signature. Such changes require modifications at the molecular level, not merely the redistribution of existing materials but transformations in how those materials interact with electromagnetic radiation. The first indications of this transformation emerged not through visual observation, but through spectrographic analysis conducted by the Venus Atmospheric Monitoring Project, a network of ground-based observatories dedicated to tracking long-term changes in our sister planet's complex atmosphere. For decades, these observatories had documented a remarkably stable spectral pattern despite Venus's turbulent cloud dynamics, a constancy that made the sudden shifts following 3 Atlas's passage all the more striking. The sulfur dioxide absorption band at 283 nanometers showed particularly notable changes, developing a distinctive split peak where previously there had been a single absorption maximum. Similarly, the carbon dioxide bands in the near-infrared region displayed subtle but measurable shifts in their vibrational rotational structure, changes consistent with altered molecular binding energies, rather than simple concentration differences. These spectral anomalies initially confused researchers, who questioned whether instrumental errors might be responsible. Calibration tests quickly eliminated this possibility, and when independent observations from space-based platforms confirmed the same patterns, the scientific community faced an undeniable reality. Venus was reflecting light differently than it had before the encounter with 3I Atlas, the sulfuric acid droplets that form the bulk of Venus's upper cloud layer, typically spherical particles approximately 1 micrometer in diameter, seemed to have developed new structural configurations. Scattered light measurements suggested the presence of more complex geometries, elongated droplets, crystalline structures, or perhaps entirely new molecular arrangements that created different patterns of constructive and destructive interference when interacting with incoming radiation. The precision of modern spectroscopy revealed changes so subtle they would have been invisible to earlier generations of astronomers. Shifts of mere picometers in absorption line centers pointed toward altered molecular binding states. Small but significant changes in the width of certain spectral features suggested new energy transfer processes occurring between atmospheric constituents. It was as though Venus had begun speaking with a slightly different accent, the same vocabulary of chemical elements, but arranged according to new grammatical rules that subtly transformed their expression. Computational chemists worked to model these changes, seeking molecular configurations that could explain the observed spectra, while atmospheric physicists developed simulations to understand how such changes might propagate through Venus's complex circulation patterns. Beyond changes in visible light, alterations appeared across the electromagnetic spectrum, from ultraviolet wavelengths, where Venus normally absorbs most incoming radiation, to infrared, where it both absorbs and emits according to its thermal properties. In the ultraviolet range, new absorption patterns emerged in the planet's spectral signature, suggesting the presence of molecules capable of capturing high-energy photons that previously passed through the upper atmosphere. In the infrared, emission lines appeared at frequencies associated with carbon-nitrogen bonds, molecular structures rarely detected in Venus's atmosphere before the encounter. Together, these spectral shifts create a new electromagnetic voice for the shrouded planet, not dramatically different from its previous signature, but distinct in subtle ways that suggest the introduction of new chemical possibilities into an ancient planetary system. The ultraviolet alterations proved particularly intriguing to astrobiologists, who noted similarities between the new absorption patterns and those created by certain organic compounds. While Venus's surface conditions preclude most forms of life as we understand, its crushing pressures combined with temperatures sufficient to melt lead, its upper atmosphere occupies a more temperate zone where complex chemistry might potentially flourish. The detection of new carbon-nitrogen bonding patterns raised speculative whispers among researchers studying the boundaries of potential habitability. Could 3I Atlas have introduced not just new chemical catalysts, but perhaps even biologically relevant compounds formed in the interstellar medium? The data remained insufficient for definitive conclusions, but the question itself transformed how some researchers viewed potential connections between interstellar material and planetary chemistry. Thermal emission spectra revealed equally puzzling changes. Venus had long been known for its extreme greenhouse effect, a runaway warming process driven primarily by carbon dioxide, but enhanced by sulfur compounds and water vapor. Following the encounter, subtle shifts appeared in how the planet's atmosphere trapped and re-radiated heat. Certain infrared wavelengths that had previously been absorbed effectively by atmospheric gases now showed slightly increased transmission rates, while others displayed enhanced absorption. The overall energy balance remained largely unchanged. Venus maintained its extreme surface, temperature, but the specific pathways through which energy flowed into and out of the planetary system had been subtly reconfigured, as though the greenhouse mechanism had been re-engineered with slightly different spectral priorities. Perhaps the most curious aspect of these optical changes involves their distribution across the planet's surface. Rather than appearing uniformly throughout Venus's atmosphere, the new reflective properties manifested most strongly in distinct bands circling the planet at specific latitudes, creating something like rings of altered chemistry at approximately 30 degrees north and south of the equator. These bands appeared to follow patterns in the planet's atmospheric circulation, suggesting that whatever caused the changes was distributed by existing wind currents, rather than settling randomly across the cloud tops. More intriguing still, these bands slowly shifted position over subsequent months, migrating gradually toward the poles as though following some predetermined pattern of distribution. Such organized behavior suggests not random contamination, but processes operating according to principles we have yet to fully comprehend. The the gradual unfolding of effects that may continue for years or decades. After the initial encounter that triggered Disturbances Part 2, Atmospheric Dynamics and Chemical Propagation, the distinctive banding pattern of these atmospheric changes corresponds closely with Venus's Hadley cells, atmospheric circulation patterns that transport heat from equator to poles through convective rising and sinking of air masses. While Earth typically maintains two such cells in each hemisphere, Venus, with its slower rotation and more energetic atmosphere, develops more complex circulatory structures. The 30-degree latitude bands where changes first manifested represent convergence zones, where rising equatorial air begins its poleward journey, creating ideal conditions for the concentration and chemical processing of any new compounds introduced into the atmosphere. This alignment with existing circulatory patterns suggests that 3I Atlas's influence, whether through direct material deposition or through perturbation of existing atmospheric processes, became amplified through Venus's natural atmospheric machinery. Tracking these bands has become a central focus for planetary monitoring programs. Advanced imaging technologies deployed by both Earth-orbiting satellites and dedicated Venus orbiters have documented their slow migration toward higher latitudes, revealing complex oscillatory behaviors rather than simple linear movement. The bands occasionally split, merge, and develop spiral structures at their boundaries, creating patterns reminiscent of self-organizing chemical systems studied in terrestrial laboratories. Some researchers have drawn parallels to Belousov-Zhabotinsky reactions, chemical oscillators that spontaneously produce complex spatial patterns through reaction-diffusion processes. The suggestion that Venus's entire atmosphere might now be functioning as a planetary-scale chemical oscillator, driven by catalytic processes initiated during the interstellar encounter, has inspired new theoretical frameworks for understanding how complex chemical systems might develop in planetary atmospheres. Time-lapse imaging reveals these bands not as static features but as dynamic wave-like structures propagating through the atmosphere. Their movement appears influenced by Venus's mysterious super-rotation, the planet's atmospheric circulation pattern that moves 60 times faster than the planetary surface below, completing a full revolution in just 4 Earth days. This super-rotation provides a mechanism for rapidly distributing chemical changes throughout the Venusian atmosphere, allowing any catalytic processes triggered by the encounter to affect vast regions of the planet within relatively short timeframes. Computational fluid dynamics models suggest that within a year of initial contact, materials introduced during the 3I Atlas encounter could have been transported throughout virtually all of Venus's atmospheric volume, though with concentration patterns strongly influenced by the planet's circulation cells atmospheric. Chemists have proposed various mechanisms by which a relatively small quantity of interstellar material might trigger widespread changes in Venus's atmosphere. Catalytic cycles involving transition metals could amplify the effect of even trace amounts of certain compounds, with each catalyst molecule potentially facilitating thousands or millions of reactions before becoming inactive. Similarly, chain reactions involving free radicals could propagate chemical changes far beyond the initial introduction point, particularly in Venus's upper atmosphere, where ultraviolet radiation provides abundant energy for initiating such processes. The most intriguing proposals involve autocatalytic systems, chemical processes that generate their own catalysts as reaction products, potentially creating self-sustaining chemical transformations that continue long after the initial trigger has dissipated. Deep within Venus' multi-layered cloud system, additional changes have been detected that may relate to these surface phenomena. The middle and lower cloud layers, composed primarily of concentrated sulfuric acid droplets and various sulfur compounds, have shown altered particle size distributions since the encounter. Radar measurements penetrating these lower layers reveal increased variability in droplet dimensions and possibly new crystalline structures forming within the liquid acid medium. Some researchers speculate that 3I Atlas may have introduced microscopic solid particles that now serve as nucleation sites for condensation and crystallization within Venus's clouds, creating new physical structures that alter not just the atmosphere's chemistry but its microphysical organization. The Most speculative interpretations of these optical changes involve theories about photochemical processes triggered by the introduction of novel catalysts into Venus' atmosphere. Certain molecules can facilitate chemical reactions without being consumed themselves, enabling transformations that would otherwise require extreme conditions or remain entirely inaccessible. If 3I Atlas introduced even trace amounts of such catalytic compounds, perhaps exotic metals or complex organic structures formed through processes unique to interstellar space, they might gradually transform Venus's atmospheric chemistry through cycles of reaction that continue long after the initial seeding. We drift through these possibilities now, imagining planetary-scale chemistry gradually shifting direction under the influence of molecular visitors from beyond our system, microscopic architects introducing new chemical pathways into an ancient planetary laboratory. The interstellar object designated 3I Atlas itself represents an extraordinary scientific opportunity, only the third confirmed visitor from beyond our solar system ever documented by astronomers. Unlike its predecessors Oumuamua and 2I Borisov, 3I Atlas approached the inner solar system on a trajectory that brought it remarkably close to Venus, passing within just 30,000 kilometers of the planet's cloud tops. This cosmic near-miss, a distance less than 3 Venus diameters, created conditions for potential material exchange that would have been impossible during the more distant passages of previous interstellar visitors. Gravitational interaction with Venus measurably altered 3I Atlas's trajectory, confirming the reality of this close encounter and providing precise data about the object's mass and composition based on the specifics of its deflection. Remote observations of 3I Atlas during its approach revealed a complex object, approximately 500 meters in diameter with irregular surface features and possibly a loosely bound internal structure similar to a rubble pile. Spectroscopic analysis conducted during its passage through the inner solar system indicated an unusual composition rich in carbon, nitrogen, and various metals, elements common throughout the universe but arranged in molecular structures rarely encountered in our solar system. Particularly notable were absorption features suggesting the presence of complex organic compounds, including possible polycyclic aromatic hydrocarbons and various cyanide-based molecules, all bearing isotopic ratios distinct from those typically found in solar system materials. These chemical signatures provided compelling evidence that 3I Atlas originated in another star system, carrying with it a chemical inventory shaped by different formation conditions than those that created our own planetary neighborhood. As 3I Atlas approached Venus, observations from Earth and space-based platforms documented a subtle but significant outgassing process, the release of volatile materials from the object's surface as it was heated by increasing solar radiation. This process, similar to the activity observed in comets but with distinctive chemical signatures, created a tenuous cloud of gas and dust surrounding the interstellar visitor. Computational models suggest that Venus's upper atmosphere would have interacted directly with this material during closest approach, potentially incorporating molecules and dust particles from 3I Atlas into its own atmospheric system. Even a relatively small mass transfer, perhaps just kilograms or tons of material, from an object measuring hundreds of meters across could introduce billions upon billions of molecules with novel catalytic properties into Venus's complex atmospheric chemistry. The timing correlation between Venus's spectral changes and 3I Atlas's passage provides compelling circumstantial evidence for a causal relationship, particularly given the distinctive latitude bands where changes first appeared. Modeling of Venus's upper atmospheric winds suggests these bands correspond precisely to regions where material from 3I Atlas would most likely have been deposited based on the geometry of the encounter. The gradual migration of these bands toward the poles follows predicted patterns of atmospheric transport, as though tracking the movement of introduced materials through Venus's circulatory systems. While correlation does not necessarily indicate causation, the specific spatial and temporal patterns observed align remarkably well with what would be expected if 3i Atlas had indeed triggered the observed changes. Since leaving the inner solar system, 3i Atlas has continued its journey outward, carrying with it whatever Venusian materials it may have gathered during the encounter. Spectroscopic observations during its departure revealed subtle but measurable changes in its own surface composition, with new absorption features possibly indicating the presence of sulfur compounds similar to those found in Venus's upper atmosphere. This suggests the encounter created not a one-way transfer, but a genuine exchange, each body incorporating some small fraction of the other into its composition, creating a permanent physical connection between a wandering interstellar messenger and a planet bound to our sun. The poetry of this exchange has not been lost on those studying the encounter, who note that it represents perhaps the first documented material connection between our solar system and the vast interstellar spaces beyond. For researchers studying interstellar objects, 3i Atlas represents not just a scientific curiosity, but a potential messenger carrying information about distant star systems. Its chemical composition, particularly its isotopic ratios and molecular structures, provides clues about the environment in which it formed, potentially revealing details about a planetary system we may never be able to observe directly. The fact that such an object could then influence Venus's atmospheric chemistry suggests a mechanism for material and chemical information exchange between star systems, a cosmic cross-pollination occurring over timescales of millions or billions of years as objects ejected from one planetary system eventually encounter others in their long journeys through the galaxy. Some astrobiologists have proposed that such exchanges could potentially transport not just chemical compounds, but perhaps even microscopic biological materials between star systems, creating a network of potential chemical or even biological information transfer spanning our entire galaxy. Part 4. The philosophical dimensions, the boundary between scientific observation and imaginative interpretation, has always been more permeable than we might wish to admit. The most rigorous measurement still requires a mind to assign it meaning. The most careful calculation still emerges from human hands. Not everything must be definitively proven to hold significance in our understanding of cosmic relationships. Some mysteries function best when they remain partially unsolved, creating spaces where wonder can breathe alongside knowledge. The potential interaction between 3i Atlas and Venus exists in precisely such a space, neither entirely proven nor disproven, but rather suspended in the realm of meaningful possibility. We approach this uncertainty not with frustration, but with the calm curiosity of those who understand that the universe reveals itself gradually, through patterns that sometimes require centuries to become visible. This philosophical approach to scientific uncertainty represents not a retreat from rigorous investigation, but rather a mature relationship with the limits of knowledge. Throughout history, scientific progress has often emerged not from immediate certainty, but from productive engagement with ambiguity, from the willingness to explore multiple interpretations of available data while continuing to refine observational techniques. The Venus-Atlas encounter provides an ideal context for such engagement, offering sufficient evidence to establish correlation while leaving questions of causation open to ongoing investigation. Rather than demanding premature closure on these questions, the scientific community has largely embraced this ambiguity as an opportunity for creative hypothesis generation, interdisciplinary collaboration, and the development of new observational strategies that might eventually resolve the mystery one way or another. The spatial and temporal patterns observed in Venus's atmospheric changes, particularly their organized banding and gradual migration, suggest processes more complex than simple contamination. Random deposition of foreign materials would likely produce patchy, irregular distributions, rather than the coherent structures observed circling the planet at specific latitudes. These patterns hint at underlying principles of self-organization, the tendency of complex systems to develop ordered structures spontaneously when provided with appropriate energy flows and feedback mechanisms. Similar principles have been observed in systems ranging from chemical reaction networks to biological ecosystems, suggesting that Venus's atmosphere may be demonstrating fundamental organizational properties that transcend the specific materials involved. The possibility that 3I Atlas might have triggered such self-organizing processes by introducing novel chemical components raises profound questions about how planetary systems respond to external perturbations, questions that extend beyond this specific encounter to encompass broader theories of planetary evolution and stability. The history of astronomy teaches us that observation always occurs through conceptual frameworks that shape what we perceive and how we interpret it. When Galileo first turned his telescope toward Venus and observed its phases, he saw evidence supporting the Copernican model of the solar system, not because the phases themselves proved Earth orbited the Sun, but because he viewed them through a conceptual framework that made such an interpretation possible. Similarly, our observations of the Venus-Atlas encounter occur through contemporary frameworks of planetary science, astrobiology, and complex systems theory, intellectual lenses that enable certain interpretations while perhaps obscuring others. Future observers, equipped with concepts we cannot yet imagine, may perceive aspects of this cosmic meeting invisible to our current understanding, patterns and relationships that exist in the data but remain beyond our conceptual reach. We drift through this thought now, feeling how it liberates us from the need for immediate certainty, how it opens space for multiple interpretations to coexist as potential pathways toward deeper understanding. This recognition of conceptual limitations extends beyond the specific case of Venus and 3I Atlas to encompass fundamental questions about scientific epistemology, about how we know what we know, and how we might know differently. The history of science demonstrates repeatedly that significant conceptual shifts often emerge not from new observations alone, but from new frameworks of interpretation that transform the meaning of existing data. The Copernican revolution, quantum mechanics, plate tectonics, and numerous other scientific transformations involve not just seeing new things, but seeing familiar things differently, perceiving new patterns and relationships within already available information. The Venus-Atlas encounter may similarly contain implications that will become apparent only through future conceptual innovations, as researchers develop new theoretical frameworks capable of recognizing patterns currently invisible to contemporary science. The boundary between knowledge and mystery serves not as a wall but as a fertile borderland where science and imagination engage in continuous dialogue. In this liminal space, observation provides constraints within which interpretation moves, while imagination suggests new directions for observation to explore. The encounter between 3I Atlas and Venus exists primarily in this borderland, a phenomenon sufficiently documented to establish its occurrence yet sufficiently subtle to leave its meaning open to multiple readings. Some researchers focus on the documented changes in Venus's atmosphere, seeking explanations through known physical and chemical processes. Others allow themselves to consider more speculative possibilities, not as definitive answers, but as hypotheses that might eventually guide the development of new observational tools or theoretical frameworks. We recognize in this approach not weakness, but the strength of a mature science comfortable with uncertainty, one that values questions at least as highly as answers, that understands how mystery itself often serves as the most productive engine of discovery. Part 5. Chemical transformations and catalytic possibilities. The specific chemical changes observed in Venus's atmosphere following the encounter suggest processes more complex than simple mixing or contamination. The appearance of new carbon-nitrogen bonds in particular has drawn significant attention from atmospheric chemists. As such structures typically require specific catalytic conditions to form within the temperature and pressure regimes found in Venus's upper clouds. Terrestrial laboratory studies have demonstrated that certain transition metals, particularly iron, nickel, and cobalt, can catalyze the formation of carbon-nitrogen compounds from simpler precursors under conditions similar to those found in Venus's atmosphere. Spectroscopic analysis of 3I Atlas during its approach indicated the presence of various metal compounds in its composition, raising the possibility that the interstellar visitor might have introduced effective catalysts for carbon-nitrogen chemistry into Venus's atmospheric system, more complex catalytic. Cycles may also be involved in the observed transformations. Autocatalytic processes, chemical reactions, that produce their own catalysts as products, could potentially amplify the effect of even minimal material transfer between 3I Atlas and Venus. Such self-reinforcing chemical systems have been studied extensively in origin of life research, where they're recognized as potential precursors to biological metabolism, chemical networks capable of self-maintenance and growth through cycles of reaction that generate their own catalytic components. While Venus's extreme conditions make conventional life unlikely, the planet's cloud layers might potentially support complex autocatalytic chemistry, particularly if novel catalysts or reaction pathways were introduced during the interstellar encounter. Some researchers have proposed that the observed latitudinal bands of altered atmospheric chemistry represent the development of self-sustaining reaction networks, chemical systems that, once initiated by the introduction of catalytic materials from 3I Atlas, continued to propagate and evolve according to their own internal dynamics. The altered sulfur chemistry observed in Venus's clouds presents another fascinating dimension of potential transformation. Sulfur's chemical versatility, its ability to form compounds in multiple oxidation states and to create both covalent bonds and coordination complexes with various metals, makes it particularly responsive to catalytic influences. Spectrographic data indicates shifts in the relative abundances of different sulfur oxidation states following the encounter, with subtle increases in reduced forms such as elemental sulfur and hydrogen sulfide, alongside decreases in more oxidized forms like sulfur dioxide. Such redox shifts suggest catalyzed electron transfer processes occurring within the cloud system, reactions that might be facilitated by metal catalysts or organic compounds introduced during the encounter with 3I Atlas. These subtle changes in sulfur's oxidation landscape contribute significantly to the altered spectral signature observed from Earth, as different sulfur compounds interact with light in distinctive ways based on their electronic configurations. Laboratory simulations attempting to reproduce Venus's altered atmospheric chemistry have yielded intriguing but incomplete results. Research teams working with simulated Venusian atmosphere in reaction chambers have demonstrated that introducing certain metal catalysts, particularly those containing nickel, iron, or platinum, can indeed trigger changes in sulfur chemistry and carbon-nitrogen bond formation, similar to those observed on Venus following the encounter. However, reproducing the spatial organization and propagation patterns observed in the actual Venusian atmosphere has proven more challenging. The complex interactions between chemistry, fluid dynamics, and radiation transport that shape Venus's atmospheric behaviors are difficult to capture in laboratory-scale experiments, highlighting the value of Venus itself as a natural laboratory for studying these processes at planetary scale. Several space agencies are now developing enhanced observation missions specifically designed to monitor the ongoing evolution of these atmospheric changes, hoping to capture crucial data about how chemically altered systems propagate and develop within planetary atmospheres. Perhaps the most speculative but scientifically intriguing possibilities involve potential connections to prebiotic chemistry, the complex organic reactions that may precede the development of biological systems. While Venus's surface conditions preclude conventional life, its cloud layers occupy a more temperate regime where complex chemistry might potentially flourish. The detection of new carbon-nitrogen compounds following the 3I Atlas encounter has prompted some researchers to consider whether interstellar material might introduce chemical pathways relevant to prebiotic evolution, processes that, while not leading to actual life under Venusian conditions, might nevertheless demonstrate principles relevant to how biological complexity emerges from simpler chemical systems. Such considerations remain highly speculative, but highlight the potential significance of interstellar material exchange for understanding chemical evolution throughout the cosmos. The most advanced computational models of Venus's atmospheric chemistry now incorporate potential catalytic processes triggered by materials consistent with 3 Atlas's observed composition. These simulations suggest that even small quantities of certain catalytic compounds could indeed trigger cascading chemical changes throughout Venus's atmosphere, particularly given the energy available from ultraviolet radiation and the efficient mixing provided by the planet's vigorous circulation patterns. While such models cannot definitively establish what occurred during the actual encounter, they demonstrate the plausibility of significant chemical transformation resulting from minimal material exchange, a principle with potentially profound implications for understanding how planetary atmospheres might be influenced by seemingly minor perturbations from external sources. Perhaps the most profound aspect of this encounter involves not what we know or don't know about its physical effects, but rather how it challenges our understanding of cosmic relationships. Traditional astronomy tends to view planets as isolated systems, their evolution determined primarily by internal processes and interactions with their parent star. The possibility that an interstellar wanderer might influence planetary development, even in subtle ways, suggests a more interconnected cosmos, one where distant star systems may exchange not only light and gravity, but material influences that shape how worlds evolve. This perspective resonates with emerging understandings in other scientific domains, from ecology's recognition of far-reaching relationships between seemingly separate ecosystems to quantum physics demonstration of non-local connections between particles separated by vast distances. We drift through this more interconnected understanding of cosmic relationships now, feeling how it transforms our perception not just of the Venus-Atlas encounter, but of our own place within a universe where nothing exists in true isolation, where everything participates in networks of influence, extending across both space and time. This interconnected view of cosmic processes aligns with emerging perspectives in astrobiology that consider the potential for material exchange between star systems over evolutionary timescales. The concept of panspermia, the hypothesis that life might spread throughout the galaxy by hitchhiking on objects moving between star systems, has gained renewed attention following observations of interstellar objects like 3I Atlas. While full biological transfer requires specific conditions that may be exceedingly rare, the exchange of complex organic compounds and catalytic materials between planetary systems may occur more frequently. Such exchanges could potentially influence chemical evolution on recipient worlds, perhaps even facilitating prebiotic processes that might eventually contribute to the emergence of indigenous life. The Venus-Atlas encounter provides a documented example of just such an exchange opportunity, a moment of contact between worlds that developed in entirely different stellar environments, potentially sharing chemical information accumulated through billions of years of separate evolution. The timescales involved in such cosmic exchanges add another dimension to our understanding of planetary development. Venus has orbited our Sun for more than 4 billion years, evolving through complex stages that transformed it from a potentially habitable world to the hellish environment we observe today. 3I Atlas likely traveled through interstellar space for millions or even billions of years before entering our solar system, carrying with it chemical signatures from its original star system and perhaps from other cosmic environments encountered during its journey. Their brief encounter, lasting mere hours as the interstellar object passed close to Venus, connected these vastly different time frames, creating a moment of contact between materials that had evolved along entirely separate paths for eons. The potential for such fleeting encounters to influence subsequent planetary evolution suggests a cosmos where development occurs not just through steady internal processes, but through occasional moments of exchange with the wider galactic environment. Pattern of development that includes both gradual change and sudden perturbation from external sources. Astronomers have begun reassessing historical observations of Venus in light of this encounter, searching for evidence of previous similar events that might have influenced the planet's development. While modern observational technologies provide unprecedented detail, astronomical records extend back centuries, and Venus, as one of the brightest objects in Earth's sky, has been studied since the dawn of astronomy. Careful analysis of historical spectroscopic data reveals subtle but potentially significant variations in Venus's atmospheric signature over the past century, with several periods showing spectral shifts that might indicate changes similar to those now observed, though less pronounced. While such historical data lacks the precision of modern observations, these potential patterns raise the intriguing possibility that Venus may have experienced previous encounters with interstellar material, that the current event may represent. Not an anomaly, but one instance of an ongoing process of galactic material exchange that shapes planetary evolution throughout our galaxy. The statistical likelihood of such encounters provides another fascinating dimension for consideration. Astronomers now estimate that thousands of interstellar objects similar to 3I Atlas pass through our solar system annually, with most remaining undetected due to their small size and minimal interaction with the inner planets. Over Venus's multi-billion-year history, it has likely experienced numerous close passes from such objects, with each encounter presenting an opportunity for material exchange. While most such encounters would involve minimal transfer, perhaps just dust particles or molecular traces, the cumulative effect over billions of years could potentially influence atmospheric evolution. This statistical perspective suggests that planets throughout our galaxy may regularly incorporate small amounts of interstellar material into their compositions, that planetary chemistry may include not just elements from a world's original formation, but traces of countless encounters with wandering messengers from other star systems. The concept of exchange between cosmic travelers carries poetic resonance beyond its scientific implications. Just as early human cultures exchanged goods, ideas, and biological material through their wanderings, reshaping each other through these interactions despite vast differences in language and worldview, perhaps planets and interstellar objects participate in their own form of cosmic commerce, trading particles and influences across the void. Venus may have received more than it gave in this exchange, the massive planet capturing dust and molecules from the relatively tiny visitor, yet 3I Atlas likely carries with it some microscopic sample of Venusian atmosphere, atoms and compounds, captured as it passed through the outermost reaches of the planet's gravitational influence. These particles will travel onward, perhaps eventually reaching other star systems, other worlds, carrying with them some trace signature of our solar family. We imagine this endless exchange now, this cosmic cross-pollination occurring throughout the galaxy, each world gradually incorporating elements from beyond its local environment, each wanderer carrying messages written in matter from one stellar neighborhood to another. Part 7. Future investigations and continuing mysteries. As our journey begins its gentle arc away from Venus, we see the golden world in hindsight, a planet touched by a visitor it will likely never encounter again. Whether the changes observed in its atmosphere were direct results of this cosmic passing, or merely coincidental shifts in a complex system, the encounter has undeniably reshaped our questions about interstellar influence on planetary bodies. Sometimes these questions themselves become the most luminous aspect of any discovery, not the answers, which remain tentative and subject to revision, but the quality of curiosity that emerges when familiar patterns are subtly disrupted. Venus continues its patient orbit, perhaps carrying within its clouds particles that traveled thousands of light-years before finding this temporary home. 3I Atlas continues its journey outward, perhaps bearing microscopic traces of Venusian atmosphere as it moves towards stars we cannot name. The scientific response to these observations has developed along multiple parallel tracks, each approaching the mystery from different methodological perspectives. Observational programs have expanded dramatically, with both ground-based and space-based instruments dedicated to continuous monitoring of Venus's evolving atmospheric signature. New spectroscopic techniques with enhanced sensitivity have been deployed specifically to track the carbon-nitrogen compounds and altered sulfur chemistry that appeared following the encounter. Computational modeling has advanced in parallel, with specialized simulations designed to explore potential chemical and physical mechanisms by which interstellar material might influence planetary atmospheres. Laboratory research completes this triad, with experimental chemists creating analog environments to test specific hypotheses about catalytic processes and reaction networks that might explain the observed changes. This multimodal approach reflects scientific wisdom accumulated through centuries of investigation, the understanding that complex phenomena require examination through multiple complementary methodologies, with each approach revealing aspects of the mystery invisible to the others. Several space agencies have accelerated plans for new Venus missions in response to these developments, recognizing both the scientific opportunity presented by the ongoing atmospheric changes and the potential significance of understanding interstellar planetary interactions. Proposed missions include specialized atmospheric probes designed to sample the altered chemistry directly, long-duration orbiters equipped with advanced spectroscopic instruments, and even balloon platforms capable of floating within Venus's cloud layers to conduct in situ chemical analysis. These missions face significant engineering challenges. Venus's extreme conditions have always made it a difficult target for exploration, but the potential scientific returns have justified unprecedented investment in developing technologies capable of surviving and operating within this harsh environment. The earliest of these new missions may reach Venus within 5 years, providing crucial data about the longer-term evolution of the changes initiated during the 3I Atlas encounter. Beyond Venus itself, astronomers have intensified efforts to identify and characterize additional interstellar objects passing through our solar system. New detection methodologies optimized for finding small, fast-moving objects have been implemented at observatories worldwide, while computational techniques for distinguishing interstellar visitors from conventional solar system bodies have grown increasingly sophisticated. These efforts have already identified several additional interstellar objects traversing our system's outer reaches, though none with trajectories that will bring them close to the inner planets during current passages. Each such detection provides additional data points for understanding the population of interstellar wanderers, their typical compositions, sizes, velocities, and frequencies, information crucial for assessing how often planetary atmospheres throughout our galaxy might experience encounters similar to that between Venus and 3I Atlas. Theorists working at the intersection of planetary science, astrobiology, and galactic evolution have begun developing more comprehensive models for how material exchange between star systems might influence planetary development throughout the Milky Way. These models incorporate recent observations of protoplanetary disks, measurements of interstellar dust composition, and improved understanding of dynamical processes that eject objects from their home systems. Early results suggest that most planets likely incorporate at least some material originating from other star systems, that pure isolation may be exceedingly rare in galactic evolution. This perspective transforms our understanding of planetary chemistry from a closed system determined entirely by local formation conditions to an open system that continues to incorporate new materials and influences throughout its lifetime, a model with profound implications for how we conceptualize chemical and potentially biological evolution throughout our galaxy. Philosophical considerations have evolved alongside scientific investigations, with scholars exploring how the Venus Atlas encounter challenges traditional boundaries between disciplines and conceptual frameworks. The event exists at the intersection of astronomy, planetary science, atmospheric chemistry, and astrobiology, requiring intellectual approaches that transcend conventional disciplinary divisions. This boundary-crossing nature has catalyzed new collaborative structures within the scientific community, bringing together researchers from diverse specialties to develop more holistic understandings of cosmic interactions. Beyond academia, the encounter has captured public imagination precisely because it suggests connections between seemingly separate cosmic realms, because it hints at a universe more interconnected than our everyday experience suggests. Artists, writers, and cultural commentators have engaged with the scientific narrative, developing creative interpretations that explore its implications for human understanding of our place within an active, interactive cosmos. As time passes, Venus continues its atmospheric transformation, with recent observations suggesting the development of new patterns distinct from those initially observed following the encounter. The latitudinal bands have continued their migration toward the poles while developing increasingly complex internal structures, spiral formations and cellular patterns that suggest self-organizing processes rather than simple diffusion of introduced materials. Spectroscopic measurements indicate ongoing chemical evolution, with some initially observed compounds declining in concentration while new molecular species appear. These developments suggest that whatever processes were initiated during the encounter have not simply played out and stabilized but continue to evolve according to their own internal dynamics. That 3I Atlas may have triggered not just a temporary perturbation, but a sustained shift in Venus's atmospheric chemistry that continues to develop along trajectories we are only beginning to understand. The most profound questions emerging from this encounter involve not just what happened between Venus and 3I Atlas, but what similar events might mean for our understanding of cosmic evolution more broadly. If planetary atmospheres can be influenced by material exchange with passing interstellar objects, how might such encounters have shaped Earth's own development? Might our planet's chemical evolution, including potentially the processes that eventually led to the emergence of life, have been influenced by similar cosmic encounters throughout its history? And looking beyond our solar system, how might interstellar material exchange influence the development of potentially habitable worlds throughout our galaxy? These questions connect the specific case of Venus and 3I Atlas to the broadest concerns of astrobiology and cosmology, to our evolving understanding of how complexity emerges and develops throughout a universe characterized not by isolation but by ongoing exchange and interaction across vast distances of space and time. In our final contemplation of this cosmic encounter, we return to the images captured during 3I Atlas's closest approach to Venus, pictures showing the golden planet hanging in space with the dark silhouette of the interstellar visitor visible against its illuminated cloud tops. This moment of proximity between two objects of such different origins and destinies carries symbolic resonance beyond its scientific significance, a visual representation of connection between cosmic realms, previously thought separate, of material exchange between worlds that evolved in entirely different stellar environments. As 3I Atlas recedes into interstellar space, carrying with it whatever traces of Venus it may have captured during their brief encounter, and as Venus continues its atmospheric evolution, perhaps influenced by materials left behind by its interstellar visitor, we witness not an ending, but an ongoing process of cosmic relationship, a process in which our observation itself participates, creating connections of understanding that span the physical distance between these bodies and ourselves. In this network of material and conceptual exchange, we glimpse a universe more interconnected than we had imagined, a cosmos where nothing exists in true isolation, where everything participates in patterns of influence and relationship extending across both space and time.